So an array is just basically a collection. So you might have seen, if you're a supercomputer nerd, you've probably seen a RAID, which is a random array of inexpensive drives. I think it has a different name now, but it's basically a whole bunch of different hard drives that act together as one drive, and it's an array of drives. You might have also become familiar with an array of LEDs. This is actually a two-dimensional array because it has both length and width. It has rows and columns of LEDs. And this is an array of solar panels. And an array of solar panels is basically like a big old line of solar panels. So you can see that's an array of solar panels. And actually this is a two-dimensional array because we have rows and also columns. You can think of an array as a locker. And in Java, an array can only hold one thing, so think of it instead of your typical school lockers, think of it as, a smaller locker. And note that, by the way, when you look at this array of lockers, you would think that, there's 6 lockers because the highest number is 106. But in fact, there's actually 7. 1, 2, 3, 4, 5, 6, 7. So even though there's a 7th locker, the locker number is 6, and that's a source of confusion in a lot of computer scientists, and it's called an off by 1 error. So anyhow, let's shrink these lockers down, and we'll, for the scope of this example, we'll just say that arrays can hold one item at a time. So in this particular case, each locker is holding one number. So there's some good things and bad things of arrays. It does manage the data for you, so you don't need a whole bunch of variables, and you'll see what I mean in the next slide. And it's easy to use. It's very, very easy to wrangle the elements in an array. But there's pros and cons. It can only hold one type of data, so it's not okay to have an array that looks like this, where it has an integer, then a character, then a double, and then a string. You can't have that. It can only be the case that an array can only hold one particular type of item. It can't be resized. So if you create an array, let's say it's an array of size 3, and you want to add something to it, so say you want to add a number right in this spot at the end, well, the problem is that 3 doesn't belong anywhere. So what you have to do is you have to create another array that's size 4, transfer all the numbers, and then move that 3 back in there. And that's the same for insertions and deletions. That's kind of a pain in the neck. So you might be saying to yourself, why do I need to have an array? I can just have a whole bunch of variables. For instance, if I was creating a grade book, I would have 30 variables called grade 1, 2, 3, all the way up to 30. Well, besides contracting carpal tunnel syndrome, it's easy. That's an awful lot of typing, and it's easy to make a mistake. So in this one, we have int average, and the average should be when we add up all the grades, and this is an awful lot of typing. Oh, and don't forget that for this we need to have a semicolon because it's a statement. And then also, on second thought, and I'm just going through my inner monologue here, the average actually has to divide all of those by 30, and then we can put the semicolon. So there's an awful lot of wrangling that needs to be done and a lot of room for error. So when you use an array, and hopefully I've convinced you of the power of an array, when you use an array, first you have to declare the array. And when I say declare, what I mean is you have to tell the computer, hey, I have an array of size 5, of size 10, of 20, and it's going to hold integers or it's going to hold strings. So you have to declare it. Then you have to populate it. And that means you have to give it values because when you declare it, it's empty, and then you have to give it breathe some life into it. Then once it's populated, you can retrieve and modify the contents for it. To declare an array, there's a few different ways you can do it. You can do int, then these brackets, grades equals new int, and in this case 7, which means it's going to allocate an array of size 7. 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 elements there. You can also create it this way. You can say int grades and put the brackets here and say new int 7. That's valid too. There's actually a few other ways, but these are the most common. I believe that this first one is the easiest way. It just makes sense because the int brackets corresponds with the int brackets and the size right there. Now for populating the array, and we already have one that exists, it's size 7, you can do grades sub 1 equals 7. That's how we talk about it, so this bracket means sub 1. grade sub 1 equals 7, and this is what we think it should look like. Oh yeah, you're sticking a 7 in the first element. Unfortunately, that's not true. You're actually sticking it in element number 1. So each element has an index. So index 0, 1, 2. This is called a zero index count. And arrays always work on this philosophy. So if you wanted to stick something in that first element, which is index 0, that would be sub 0, you'd say grades sub 0 equals 8. And then the 8 appears in the index 0, the first element. All right, here's how you populate an array. First you declare, boom, done. Int grades equals new int 7, so we have 7 elements. Notice that the index goes up to 6. Grade sub 1 equals 7. Okay, so we know what that looks like, so that 7 should probably appear right where the cursor is. The next one is grade sub 5 equals 6, so that means index 5 right here, which is actually the 6th element, 0, 1, so this is 1, 2, 3, 4, 5, 6. That should be 6. Alright, that makes sense so far. Int x equals 3, okay, so we know x is 3. Grades sub x equals 9. That's the same as saying grades sub 3 equals 9. So we would expect that right here, grades sub 3 would inherit the value 9. And it does. But it gets even fancier because you can say grade sub 4, which is this box right here, equals x plus 2. So I know the number's going to appear here because this is index 4. And I know that x is 3 from this declaration up here. So this is 3 plus 2. So index 4, which is the 5th element, the grade sub 4 is going to equal 5 because that's 3 plus 2. And it does. The last thing, and this is going to get really fancy, is grade sub 0. So that would appear here. Grades sub 0 equals grades sub 1 minus 1. So I know the answer is going to be here. Grades sub 1 is 7 minus 1. So 7 minus 1 is 6. So we should get a 6 appearing in sub 0. Sub 0. So let's go over another example. We can say for int I equals 0. So this is a for loop. I is going to start at 0, end at 7, and it's going to increase by 1. Grades sub I equals I times I. Now this looks complicated, so what I do is I draw a little table. Sometimes I do this on a piece of paper. And so this is column I. So I is going to start at 0 and work its way to 6 because it's actually less than 7. And this is what grades sub I equals. So when I is 0, grades 0 equals 0 times 0. So that should be 0. Now I is 1 because it's going to increase. So grades sub 1, I know that's going to go here, is going to be 1 times 1. Yeah, that's 1. All right. So now we're going to increase the value of I to 2. So grades sub 2, that's going to go here, is going to equal 2 times 2, which is 4. I is going to now equal 3 because it's incremented. So grades sub 3, okay, I know that's going to go here. I see a pattern. It looks like grade sub I is always going to go up. And so this ends up being squares. So let me just walk through the code. So when I is 3, grade sub 3, yep, that's going to be 3 times 3. I now becomes 4. So grade sub 4, that'll be this box, is going to equal 4 times 4, which is 16, 25, 36. That's a little complicated, but if you take your time and work through that code, it makes a lot of sense. And by the way, there is a cheater way to declare and populate array all at once, and that would be this nomenclature in brackets, grades equals, and then you can populate it right then and there. Although that's usually not done, we use it for demonstrative purposes, or if you have specific cases where you don't need to be changing the contents of the array. So this is what it looks like, no big surprises. There is a method called length, and a method is something new, and a method is something you can do to an object, and this array is the object. So I'm going to declare an array called test array, and it's going to have 7 elements, and I'm going to populate it on the fly. I'm going to do system.out.println, the length of the array is, and I'm going to append to that, I'm going to concatenate testarray.length. So testarray.length calls upon the computer knows that dot length of an array. It counts it up. It's like 1, 2, 3, 4, 5, 6, 7. And so it knows that the length of this array is 7. So this is what you're going to get as the output. And let me show you that in action. So we're going to declare our array. And now we're going to do a loop. And this makes sense. For I equals 0, less than 7, it's going to output test array sub I plus a space. So when we run through it, it's going to say, okay, so we have for loop, test array sub 0 is 1. So it's going to output 1, then a space, then 1 and a space 2. And this is exactly what it looks like. There should be no surprise there. Now, the problem is this 7 is only good if this array is of length 7. And so you can argue, well, if I ever needed to make it longer, I'd just change the length of the array when I declare it and then also change it here. But a more universal code would be, instead of using 7, use testarray.length. And this is pretty common. So testarray.length will always be exactly how long the array is. And that's the only thing I changed in this code from the previous example here. I changed, instead of 7, I used testarray.length.